Okay, so you guys all got 45? Yes, 45? Good. Okay, how about 120? 32? And then, hold on. 180 minus 92 is... Yeah. Okay, anybody need me to go over any of these? Any at all? Yeah, well, because this is 90, right? So I did 180 minus 90, which gave me 90. And if this is x, this is also x. So there's two of them. So 90 divided by 2 gave me 45. Here I have three that are all the same. So that's 180 divided by 3. So each of these is 60. But I was looking for this outside one. This angle plus this angle gives me 180 because a straight line is also 180. So I had to do 180 minus 60 to get the 120. That was, yeah, that just... 180 minus 92 is 100 minus 12, which is 90 minus 2, which is 88. And there's two of them. There's four altogether, but there's two triangles, so there's only two in the triangle. Yeah. So 44. So vocabulary. Okay, so a median is a segment from a vertex of a triangle to the midpoint of the opposite side. So if you have a triangle, this is your midpoint. Let me do a different triangle. Hold on. Okay. Here's my midpoint. This is my median. Okay. Now, it doesn't matter, like there's no rule about the length or the angle, and it doesn't, bisect. It just hits the midpoint. That's the rule. It has to hit the midpoint. Okay, with an altitude, we have vertex perpendicular to the other side. So we have to hit at a 90-degree angle, an altitude. Now, straight down from the vertex to a 90-degree angle. Now, in some cases, an altitude, if you have an obtuse triangle, the altitude can fall outside of the triangle because it has to be perpendicular. There's no way to go from here to this side and be inside the triangle and be perpendicular. So basically, you kind of like extend the side out, pretend, and the altitude goes straight down. Always straight down to a 90-degree angle. Okay. A perpendicular bisector is any line or segment or ray or plane that is perpendicular to a segment and it bisects it. So we can have a situation sometimes where our altitude becomes a perpendicular bisector, but any side that we have that cuts through at a 90-degree angle and makes this equal to that. And then equidistance is the same distance. Here? It's the same distance. So if something's equidistant from me, like you and probably Clea are equidistant from me, most likely. So the same distance. Okay. We have, if a point is equidistant from the side of an angle, then it lies on the angle bisector. So what happens if we have an angle right? And there's some point. And this distance here and this distance here are the same. Okay? Then what happens is if you draw a line, you get a bisector. Okay, so that point is on the bisector. Then we have, if a point is on the angle bisector, so if we have an angle and we know we have a bisector, right, so this angle is the same as this angle, and we find some point on there, then we take and we find the distances, the distance here and here, the distance is always perpendicular, will be the same. Okay, obviously I didn't draw that right, but you get the idea. Okay, oh, that's no good. Okay, fixed it. All right, now we have if a point is equidistant from the endpoints of a segment. Okay, so if I have a segment and I have a point, now the point can be on the segment or it can be off of the segment. That doesn't matter which. But if this distance here is the same as this distance here, then I draw a line, it's the perpendicular bisector. And that is if the point is on the segment, so it could be here in the middle, the midpoint basically, or it can be anywhere along this axis. And vice versa, if we have a perpendicular bisector, I can find any point on that bisector, and then these distances will be the same. Okay, so these go back, like these two sets of theorems, 37 and 38, go back and forth, right? If you're equidistant from the sides of the angle, then you're on the bisector. If you're on the bisector, then you're equidistant from the sides of the angle. And then 39 and 40, if you're equidistant from the end of the segment, you're on the bisector. Or if you're on the bisector, you're equidistant from the ends of the segment. So they go both directions. AB is an altitude. What do I know about an altitude? It's perpendicular. That means that 3x minus 15 will equal 90. And then I can solve for x. So 3x equals 105, divide by 3, and x will be 35. Okay, so if you're told altitude, you know that this is 90. That's the key there. Altitude equals 90 degrees. Okay, AB is an angle bisector. That means that this distance, oh, are you really glitching? And this distance are equal. Okay, and then you solve from there. So we subtract 2x from both sides. X minus 5 equals 17. Add 5 to both sides, and I get that x is equal to 22. Okay. Here I have an altitude. I can solve this either by setting those equal, but it's an altitude, so that tells me 90 degrees. So I can pick either one of these. Which one you want to use? Okay, x plus 14 is equal to 90. X is equal to 90 minus 14, so 76. Okay. Here we have a perpendicular bisector. Perpendicular bisector means that this length and this length will be the same. So 2x plus 1 is equal to 23. 2x is equal to 22 because I subtract 1 from both sides. Then divide by 2 and I get that x is equal to 11. Here I have an angle bisector. That tells me again that these two are the same. So 6x minus 15 is equal to 3x plus 30. Take 3x away from both sides. I get 3x minus 15 is equal to 30. add 15 to both sides, and I get 3x is equal to 45 to get that x is equal to 15. Okay, so basically equal to each other or equal to 90 is what you're going to have on this. So I would like you guys to try that one.